Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is lesson 4-4 zeros and graphing. So let's get right to it. Today we are going to use the zeros of a polynomial to determine a polynomial function, and we're going to use the zeros in technology to graph a polynomial. So a couple things here. Terminology for zeros of a function. If f is a polynomial function and a is a real number, the following statements are all equivalent. X equals a is a zero or a root of the function. X equals a is a solution of the polynomial function f of x is equal to 0. X minus a is a factor of the polynomial f of x. And a0 is an x-intercept of the graph of f. So there's a lot of things that we can talk about. So if we say that x equals a is a 0, we can make a bunch of factors from that list of zeros. And that's what we're going to do in this first particular problem here. It says find a polynomial function with integer coefficients that has the given zeros. So if we have 0, 1, and 1 plus square root of 2, all right, we can change those. We have the zeros, we can change them into factors of a polynomial. So we could go x minus 0, but x minus 0 is just x. We can go x minus 1, that's the second possible factor from that 0. And then the hard one is this. It'll be x minus this whole quantity, 1 plus square root of 2. Now here's the problem. The directions say, find a polynomial function with integer coefficients. Well, square root of 2 is not an integer. And so to get rid of our square roots, what we're going to do is we're going to add, and I don't like that, so let's change it to a little thinner. Add the 0, 1 minus square root of 2 to make integer coefficients. All right, and so when you multiply a number of this form, this irrational form, by its conjugate, remember a squared, or excuse me, let's start over. Just remember a minus b times a plus b is going to be equal to a squared minus b squared. And so when I multiply these two things together, I'll get 1 squared minus square root of 2 squared, and that square root's going to cancel out for us. So I'm going to add one more 0, x minus the quantity 1 minus square root of 2. And let's multiply these two together first. So x times x is x squared. And then x times negative 1 is negative x. So we'll leave that out there. And then we can multiply these two together. And so let's do that. We'll go 1 times, or x times x is x squared. X times negative 1 minus square root 2 is going to be just that, x times 1 minus square root of 2. And then negative 1 plus square root of 2 times x is going to be negative x times 1 plus square root of 2. And then negative times a negative is a positive. 1 plus square root of 2 times 1 minus square root of 2 is just going to be that. 1 plus square root of 2 times 1 minus square root of 2. Now I'm going to leave this alone for a step just because I want to simplify this down a little bit before we move forward. And so let's see here. Let's leave this x squared alone, and then let's distribute this. So negative x times 1 is negative x, and negative times a negative is a positive. That'll be x squared root of 2. Negative x times 1 is negative x. Negative times square root of 2 will be negative x square root of 2. And then we already talked about multiplying these two together, but I'll do it all the way out so that you can see that this is true. 1 times 1 is 1. 1 times negative square root of 2 is negative square root of 2. Square root of 2 times 1 is positive square root of 2. And then positive times a negative is negative. Square root of 2 times square root of 2 is square root of 2 squared, or square root of 4, either way. And that'll just be 2. Now, you can see very quickly here that this positive x square root of 2 and this negative x square root of 2 cancel out. And this negative square root of 2 and this positive square root of 2 cancel out. Yeah. And so when I collect all my like terms, and again, I'm just going to leave this alone. So I'm going to have x squared minus x, and then this will be x squared. And then I have two x's right there, so and they're both negative, so negative 2x, and I've taken care of that. And then I have this 1 and this negative 2 here, so 1 minus 2 is going to be negative 1. So this simplifies real cleanly. And again, we'll go back up to this red. I needed to add this extra 0 in here so that when I multiply these out, I have only integer coefficients now. And so now I only have integers. In fact, I only have ones, negative 1s, and negative 2s, so we're good. So here we're going to multiply this, so I'm just going to stack it. So x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. X squared times negative 1 is negative x squared. And then we'll go negative x times x squared is negative x to the third. Negative x times negative 2x is positive 2x squared. And then negative x times negative 1 is positive x. And if I did all of my multiplications and additions correctly, my final answer is going to be x to the fourth minus 3x to the third plus x squared plus x. And I think that that is correct. All right, moving on. Find a polynomial function with a 0 of 3 that has a multiplicity of 2, a 0 of 2 that has a multiplicity of 1, and overall degree of 4. So I need a degree of 4 when I'm done. So if one of my zeros is 3, that's going to give me x minus 3 as a factor. It has to have a multiplicity of 2. So I want to put 2 there. A 0 of negative 2, and that'll give me x plus 2. Has a multiplicity of 1, so it has to be a multiplicity of 1. And an overall degree of 4. Well, if I look at this thing here that I've multiplied out so far, when I multiply this out, I'll have an x squared. And then when I multiply by this, I'll have an x to the third. That's going to give me a degree of just 3. So here's what I'm going to do. I'm going to add an additional 0, and that's just going to be x. And what that's going to do for me is that'll give me my degree of 4 that I want. And so let's multiply this out first. So x minus 3 quantity squared. Remember, you have to go x minus 3 times x minus 3. Don't be the guy that distributes exponents over subtraction. Don't be that guy. And then we have the x plus 2, and then we have the x. And so when I multiply these out, x times x is x squared. X times negative 3 is negative 3x, and then negative 3 times x is another negative 3x, giving me negative 6x, and then negative times a negative is positive. 3 times 3 is 6. So I have that times x plus 2 times x. I just bring those down. So now I'm going to multiply this term by that term. So I'm going to stack again. So x squared times x is x to the third. Negative 6x times x is negative 6x squared. And then 6 times x is 6x. X squared times 2 is 2x squared. Negative 6x times 2 is negative 12x. And then 6 times 2 is 12. And so when I add that up, I'm going to get x to the third minus 4x squared minus 6x plus 12. And so that's me multiplying this expression and this expression. So I still got to bring this times x down. And that one's just easy. I'm just going to increase the degree of each of these terms by a power of x to the first. So it'll give me x to the fourth minus 4x to the third minus 6x squared plus 12x. And I will put a box around that, and we'll be done. All right, the 0 function and the max min function of the graphic calculator. So let's pull out that graphic calculator, and let's clear this out. And let's go to a y equals, and let's clear this out. And let's talk about one of the functions that we did earlier. Let's talk about this, this one right here that I had. And I'm just going to type it in as I had it, as I set it up, x to the x minus 3 squared plus or times x plus 2 times x. And I'm just going to put it in like that. And so I'm going to say this is x minus 3 quantity squared. And then, let's see, we had x plus 2, so x plus 2, and then we have an x there. And so we have 3 zeros. At 3, we'll have a 0. At -2, we'll have a 0. And at 0, we'll have a 0, according to what we have. But if we look at the graph, we see that. And again, the double 0, the multiplicity of 2, gives us a 0 where it just comes down and touches. And then we have we have a 0 at 0 and another 0 at 2. Now, we know that those are true, and that's okay. What this particular example is trying to show is the 0 function and the max and the min function. So just kind of give us an idea. We know that this is a 4th degree polynomial. Its leading coefficient is positive, so the end behavior is up to the left and up to the right. So we know that this graph is going to come down here and eventually somewhere below our graph turn around and then come back up, and then somewhere above the graph it turns back down, and then it hits that 0 at 3, and then it goes up and goes up that way forever and never stops going up. So we want to reshape our graph so that we can see this minimum here and that maximum there. So what we're going to do is we're going to change the y values. So I hit that window button there, and the x's are fine. We don't need to change those, but we want to change our x minimum and our y minimum and our y maximum. So I'm going to, just as a first guess, I'm going to make it -20 on the y minimum, and I'll make it +20 on the y maximum. Now that's doubling the number of points, and since I don't want all those tick marks on the y-axis, I'm going to change this to a 2, and then I'll still have 20 tick marks, and it should look okay. And now we get this, and remember, each of the tick marks along the x-axis are 1, and each of the tick marks along the y-axis are worth 2. All right, so if we want to find this 0 right here, what we're going to do is we're going to hit second, we're going to hit the trace button, and all of the cool functions for this trace button are actually in the calculate button. And I know we've seen some of these before, but let's talk about the 0 function. So I'm going to hit 2 as to get a 0, and I want to get this 0 right here. So I'm going to push my right arrow key on the D-pad until my little spider guy is on the left-hand side of the 0. So I'm going to hit enter there. And then I'm going to push the right arrow key until he's a little bit on the right side of where I think that 0 is it. I'm going to hit enter there. And so I've set up a little boundary line where the graphing calculator checks to see where it changes from positive to negative or from negative to positive. So when I hit enter this third time, I find that at -2, 0, which we already discussed because -2 is a 0, we have actually found that 0. -2, 0 is the function. Now the other thing that we can do with that is we can find these maximum and minimum points. Now if you ever get to calculus, you're actually going to be able to calculate these things algebraically. The graphing calculator will do it for you right now. So if I hit second and I hit the trace button, and I want to find a minimum value, I'm going to hit 3. And similar to the 0 function, we want to be a little bit on the left-hand side of where we see that 0. So I'm going to hit enter. And then we're going to have to be on the right-hand side of where I think that minimum is. And so now it's going to look for the smallest value on this curve, the lowest value on this curve, between these two triangles when I hit enter. And so this minimum value is going to be -1.225, comma, -16.947. And then if I wanted to find the maximum, I'm going to go second, hit that trace button. Oops, let's hit second and trace, hit it twice. And then I'm going to hit 4 for our maximum. And I just want to get close to where I think that maximum is. Right there is 1 point. And then I'm going to go a little bit to the right of where I think it is. And this thing that says guess, you don't necessarily have to guess because we're only dealing with very small regions. But the guess means you want your spider guy close to the maximum value there, and we're going to hit enter. And so our maximum value for this particular one is 1.225, comma, 12.467, because that 9 rounds it up, and that 7 would round up. Okay, let's see here. That's a blank. Use the graphic calculator to find all the zeros and the relative extrema of the function and graph the function. So we're going to graph this function and we're going to label all of the values that it asks for. And so before I do any work, I already know some things about this particular function, because it's a third degree polynomial and it's got a positive leading coefficient, it's going to go down to the left and up to the right. Now, I'm not going to draw those in right now, but I do already know that without having to do any additional work. Oops, I don't want that. Come on, I don't want to see that. There we go. Okay, that's good. I also know that the x-intercept or the y-intercept is -2. So let's put this in the graphing calculator. We're going to find those relative extrema, and we know that's going to come up and it's going to go down, and then, but we don't know where it's going to go through the x-axis. It has to go through it at least once. So let's go to our y equals. Let's clear this out. It was 3x raised to the third power, and then the next one was 4x squared. So let's go plus 4x squared, and then minus 5x minus 2. So minus 5x minus 2. I hit the graph button on that, and I see these things. So it's looking like I'm going to have some decimal values in here, and that's okay. So here's what we're going to do. We're going to find those zeros first. So we're going to go second, and we're going to go trace. We're going to hit those, or find the 0. And so our first 0, a little bit to the left, hit enter. A little bit to the right, hit enter. And our first 0 is at -2, 0. So I'm going to go to -2 right there. We're going to put a 0 in there. And this is our x-axis. And then while we're at it, let's find what that maximum is. So second, trace. Let's find that maximum. Let's hit 4. A little bit to the left of where I think the maximum is. A little bit to the right of where I think that maximum is. And so I have a maximum at -1.312, 4.670, -1.312. And so right there, I have -1.312. I think that was what I had, 312, and then it was 4.670. 4.670. That's that point. And then clearly we're going to have another 0 right there. So second, trace 0. We're going to hit a 2 there. We're going to find that next 0. Hit enter. A little bit to the left, hit right, hit enter. And then at negative, it looks like this is a third. And I'm going to put that in because 0.3 repeating is a third. And so this is going to be at -1/3, 0. And then we also know that -2 is a y-intercept because -2 right there. And let's find, but you could also go trace value 0, and that'll give you the -2. Let's find that minimum. So 3 is the minimum, so let's hit that. That's pretty close. And then we'll go a little bit to the left of where we think that minimum is. And so 0.423, 3.172, 0.423. So right here is 0.423, comma, negative 3.172. And then the last 0 will be right here. It looks like it's going to end up being 1. Hit enter here and hit enter there. Yep, 1, 0. And so we'll call that 1 there. And so we're just going to connect our dots. I probably could have made that a little bit bigger. That's pretty good there. That's all I got for today, folks. So the Marvel fun fact of the day: James Spader, not only the voice of Ultron in the Avenger Age of Ultron, but he also performed the motion capture used for all the robots' movements. His speaking voice was modified to sound even more robotic. That's all I got. Have a good day. Bye.